Okay, good afternoon, everyone. Can you hear me? Is it audible?
Yes, sir.
Yes, sir.
Okay, fine. So, in the last class, we have started the periodic and aperiodic signal definition and what is the procedure to identify whether the given signal is periodic or aperiodic if a signal having more than one component. Okay, and remember that individual sine function, cosine function, complex exponential function is always periodic, irrespective of what is the t value. The formula for t value t equal to 2 pi by omega. Whatever the value for t, the signal is periodic only. Okay. So this procedure applicable only for the signal having more than one component. Particularly if the three signals given, then find the time period of each and every signal t1, t2, t3 using the formula t equal to 2 pi by omega. Using the formula t equal to 2 pi by omega. With the help of this formula, find T1, T2, T3 and T1 to T2 ratio and T1 to T3 ratio and check all the ratio T1 to T2 and T1 to T3, all the ratio and so on must be the rational number or the ratio between two rational number. For the simplicity, your resultant T1 to T2 equation should not have any root terms or any pi terms. Then the given x of t signal is periodic signal. How to find out the fundamental time period of the signal? You have to take LCM of T1, T2, T3 as per the procedure. So if you get the fractional result for T1, T2, T3, then finding LCM, then you have to recall your school mathematics. LCM of fractional number is equal to LCM of numerators and HCF of denominator. Or one simple shortcut I told you, find the LCM of denominators of all the ratios, then multiply with T1. You will get same result. Okay, it's your wish. Either you are going with this process LCM of T1, T2, T3, or LCM of denominators of all the ratios. So in this example, T1 to T3, T1 to T3. So check T1 to T2. What is the ratio? T1 to T2, 3 by 2. So denominator is 2. T1 to T3. What is the denominator value? 1. So LCM of 2 comma 1. That result should be multiplied with your T1. Okay. This shortcut method. Okay. Anyway, you have to write down your fundamental time period carefully. So if signal having minimum 3 component, then it will be lengthy. You have to do carefully. Right. So today we will continue the same topic. How to identify whether the given signal is periodic or not in continuous cases. First problem, j e power j5t. Comment on the periodicity, whether the signal is periodic or not. Okay. So I mentioned already, if the individual complex exponential signal, the individual complex exponential signal is always periodic. Okay. So this signal is a periodic signal only. Periodic signal. E power j5t, e power j omega t is a periodic signal. So what is the time period of the signal? T equal to 2 pi by omega naught. What is omega naught here? 2 pi by e power j omega naught t. So phi is the omega naught. So fundamental time period of the signal is 2 pi by 5 seconds. Okay. Right. Second problem. Sine of 50t plus 2 pi by 5. Identify whether the given signal is periodic or not. So I mentioned already, individual sine component is always periodic only. irrespective of whether your t result having pi term or root term, whatever it may be. Individual signal is always periodic. So this is a periodic signal. Okay. So this is phase angle. This is equivalent to sine of omega naught t plus theta. Okay. So forget about this theta. We need omega naught value only. So the time period of the signal t equal to 2 pi by omega naught, 2 pi by 50 or pi by 25 or pi by 25 second. Okay. So this is also a periodic signal. Next one, 4 cos 5 pi t. So individual sine component or cosine signal is always periodic. So you can write down this signal is a periodic signal. This signal is a periodic signal. The time period of the signal capital T equal to 2 pi by omega naught. 2 pi divided by omega naught. Cos omega naught t. So omega naught t here 5 pi. So pi will be cancelled. The fundamental time period of the signal 2 pi by 5 seconds. Right. So next problem. Fourth one. X of t equal to sine 10 pi t dot u of t. Okay. So far we discussed the sine function, cos function, something. Now the sinusoidal signal available in the combination with the elementary signals u of t. X of t equal to sine 10 pi t dot u of t. Comment on its periodicity now, whether the signal is periodic signal or not. Okay. So what is the definition for a periodic signal? The x of t information, that is equal to x of t plus the fundamental time period of the signal for all the values of t. That is t from minus infinite to infinite, the signal must have this property. Then only it is a periodic signal. Okay. So this kind of problem you have to sketch the signal. Say for example, a sine omega naught t, standard format. So a value here 1. Okay. So omega naught value 10 pi. Okay. So 2 pi f equal to 10 pi. So pi will be cancelled. So f equal to 10 by 2, 5 hertz. So to draw the waveform for sine 10 pi t, generally for the sinusoidal signal, we need two information. One is frequency of the signal or time period of the signal. Both are same. Okay. So f equal to 5, then your time period in terms of hertz, or t equal to 2 pi by omega naught. So 2 pi by omega naught value 10 pi. So pi equal to 1 by 5. T equal to 1 by 5. Okay. Neither way it is same. T equal to 1 by 5. And amplitude is 1. So draw the sinusoidal signal. T versus sine 10 pi t. Okay, and so on. So this is sine 10 pi t. So mention the time period and amplitude and so on. Amplitude is 1. Amplitude is 1. One complete cycle. This t value equal to 1 by 5 seconds. Okay. So this is the sketch for sine 10 pi t. But what is the problem? Sine 10 pi t dot u of t. So if you multiply this signal with u of t signal, so what is mean by u of t? Unit step.
function.
So unit step function minus infinite to 0, 0. 0 to infinite, the value is 1. So this is time axis. So if you multiply these two signal, then you will get the signal x of t having the sinusoidal function only in the positive interval. Okay. The negative interval, this information multiplied with 0, then you will get 0. Okay. So this is not a periodic signal. The same kind of information must be repeat for each and every values of capital T. So the positive value of small t, the repetition is there, but the negative value of t, it is 0. So this is not a periodic signal. So you have to write down the comment. This is, or this signal is aperiodic signal. Aperiodic signal or not a periodic signals. Okay. So you may expect any kind of signals either in the form of cosine function or sine function or e power j function or sine function, a cosine function in combination with some elementary signal like this. Okay. So you have to solve carefully. So next one. So I'm just solving the different kind of problems. Three component signal already we discussed. So now we will take two component, that is x of t equal to cos 60 pi t plus sine of 50 pi t. Identify whether this particular signal is a periodic signal or not. So function 1 plus function 2. So time period of the signal, let's say t1, time period of the signal, let's say t2. So t1 equal to 2 pi by omega, cos omega not t. So here 60 pi is your omega. Okay. So pi will be cancelled, 1 by 30. So t2 equal to 2 pi by 50 pi. Pi will be cancelled, 1 divided by 25. So t1 equal to 1 by 30. T2 equal to 1 by 25 second. Unit you should not forget. 1 by 30 second, 1 by 25 second. Now as per the formula, as per the procedure, how to identify whether the given signal is periodic or not if more than one component is available in the x of t. So step 1 over. Now step 2, find the ratio between t1 to t2. 1 by 30 divided by 1 by 25. So this will be equal to 1 by 30, 25 by 1. So 5
5
times
by
of
6.
5, 6 times of 5. Okay. So the ratio of t1 to t2 does not have any root terms or any pi terms, correct? 5 by 6. Therefore, you can write the comment. The ratio between t1 to t2 does not have any root terms or pi terms. That is, the ratio is a rational number. Therefore, the given signal is periodic signal. Right. Therefore, the given signal is periodic signal. So once you identify the signal is periodic signal, then you have to find out fundamental time period of the signal. So how to find fundamental time period of the signal? What I told you.
LCM.
Yes,
LCM.
LCM of T1, comma.
T2.
So 1 by 25 and 1 by 1 by 30, 1 by 25. You can find the LCM, then write down the result. Or here also one more shortcut. If two signals only available, it's very simple to check the total time period. What is T1 by T2? Ratio, result?
5 by 6.
6.
5 by
This will applicable only for if only two component available. 5 by 6. Just cross multiply. 6 T1 equal to 5 T2. So your fundamental time period T will be equal to either 61 or 5T2. Okay. So the fundamental time period equal to, say for example, 6 into T1. What is T1?
1 by
By
30.
30. So 1 by 30. 1 by 30. So 1 divided by 5 seconds. Or 5 T2. So 5 into T2. 5 times of T2. You will get 1 divided by 5 1. Okay. So this is simplest method. If two signals are given, you no need to go for LCM for the fractional of T1 and T2. Very simple method. Just T1 to T2 ratio. Cross multiply and your fundamental time period will be equal to either 61 or 5T2. Both will give the same result. Okay, only if 3 component given, then you have to go for the previous techniques. 2 component, just cross multiply, you will get the fundamental time period. Or if you find the LCM of 1 by 30, 1 by 25, you will get the same result. Okay. Just understanding to all of you. Individual signal, individual complex exponential, and 3 component signal and 2 component signals. Okay. Problem number 5. Okay. Next, problem number 6. X of t equal to e power j pi t. E power j pi t minus 1. Okay. Comment on its periodicity. E power j pi t minus 1. It's periodic or not?
Yes.
Periodic.
Sir.
Because individual complex exponential signal is always periodic. You forgot about this term. This term related with your phase. Okay. So it is a periodic signal. E power j pi t. It's a periodic signal. You can write this is a periodic signal. Periodic signal. The fundamental time period of the signal t equal to 2 pi by omega naught. So e power j omega t. Okay. E power j omega t plus some phase angle value. So 2 pi by pi. 2 pi by pi. Pi will be cancelled 2 seconds. Okay. So I hope all these students can able to solve periodic signal problems. Okay. In continuous time cases. If any kind of signal given, you have to follow this procedure and find out. While finding this T1 to T2 and T1 to T3 in the 3 component signal, if any one ratio having the root terms, pi terms, then the signal is a aperiodic signal. Please remember that. All the ratio must be the rational numbers. Okay. So 1 to 2 is a rational number, but 1 to 3 having root term, pi term, then the signal is a periodic, not a periodic signal. Please remember that particular point. Right. So these are all some usual problems. So some interesting problems available in your signal sense system by Opanium textbook. So there you have to apply your mind, the logical reasoning. So these are all direct formula. Okay. So problem number 7. The 7 and 8 taken from your textbook exercise problem. Identify whether the given signal is periodic or not. X of t equal to even function. Okay. The symbol indicate even function. Please remember in the question paper, if the symbol given, it represents even function of some signal cos 4 pi t dot u of t. Identify whether the signal is periodic signal or not. X of t equal to even function of cos 4 pi t dot u of t. First, you have to sketch the signal, even function of a signal. What is the formula for even function of a signal? So we studied that any continuous time signal x of t can be written as even part of the particular signal plus odd part of the particular signal. If we add even component of the particular signal, odd component of the particular signal, that will be equal to the x of t1. So the formula for even component of a particular signal, x of t plus x of minus t divided by 2. So to comment on this periodicity, first of all, we need to sketch this signal. Then with the we have to look at the nature of the signal and write whether it is periodic or not. Okay. So cos pi t 4t. How to sketch? A cos 4, sorry, A cos omega naught t in general format. Okay. A cos omega naught t. So the amplitude is 1 here. The omega naught equal to 4 pi. So time period t equal to 2 pi by omega naught. So 2 pi by 4 pi. Pi will be cancelled. So 1 by 2 second. Okay. So time period is 1 by 2 second. So cos 4 pi t sketch. First sketch cos 4 pi t. To draw the sinusoidal or cosine function, we need time period, fundamental time period of the signal as well as amplitude of the signal. So cosine waveform. Okay. Sinusoidal signal, sorry, unable to draw it clearly. Okay. Magnitude 1. So time period from this particular peak point to this particular peak point is the time period. So what is the time period here? 1 by 2 second. 1 by 2 second. So this cos 4 pi t, look at the problem, multiplied with u of t signal. Cos 4 pi t signal multiplied with u of t signal. Then for the resultant signal, you have to sketch for the even function. So 0 minus infinite to 0, 0, 0 to infinite, the magnitude is 1. So this is the sketch for u of t. So if we multiply both signal, so you will get cos 4 pi t dot u of t. Cos 4 pi t dot u of t. So these negative portions will be skipped. 0 dot this value 0. So you'll get only the positive portions of the cosine wave and so on. So this is cos 4 pi t ut. So what we need to do as per the problem, we need to sketch, let assume this is our x of t now. Let assume this is our x of t, cos 4 pi t dot u of t. Okay, or x1 of t. X1 of t, because x of t in the problem there. So let assume x1 of t equal to cos 4 pi t dot u of t. For this signal, we need to sketch even component of the signal. Okay. How to find out the even component? The formula available, x of t, right? X1 of t plus x of minus t. So x1 of minus t, then add together, then the magnitude scaled by 2. So x1 of minus t, x1 of minus t, right? How to sketch? Correct or not? So this is x of minus t. If this signal is x1 of t, then x1 of minus t, mirror image of this signal with respect to 0, or flipping of the signal in x direction. So this portion will come this side, and 0 will come right side. Okay. Now even part, even part, that is even part of cos 4 pi t dot u of t. The sketch is add these two signal. Add these two signal. X1 of t, x1 of minus t. Okay. Here it is magnitude 1. Here it is magnitude 1. Add these two signal and then magnitude is divided by 2 as per the formula. Okay. So if you add these two signal, see right side, some cosine function. Here 0. So this information plus 0, you will get the same information. Negative side, 0 plus some cosine waveform. So 0 plus this information, you will get the same information. So if you are adding these two, your resultant signal would be yes or no? For this particular signal, the magnitude is 1. As per the formula, 1 by 2 of x of t plus x of minus t, then this would become 0.5. So instead of giving the signal directly to the student, the questions available in the form of even function of cos 4 pi t dot u of t. So sketch cos 4 pi t dot u of t first. This is the signal. For this signal, find the even component. What is the formula to find the even component? X of t signal plus x of minus t. Add together. Finally, the magnitudes are scaled by 1 by 2. Right? Let us assume this signal is a new signal. So x1 of t, x1 of minus t. Add these together, you will get this. Now, can you comment on this? Whether this one is periodic or aperiodic? Why this much of time you are taking to answer?
Periodic, sir.
Periodic or not?
Yes, sir.
Periodic. Okay, because
Periodic.
it follows the again the cosine waveform. See,
Sir,
here from
magnitude
here,
change in the sir.
magnitude knows you. Magnitude knows.
Every time
Yeah. Even the signal shifted up and down also, it is a periodic signal. Now look at this particular signal and tell me the signal is periodic or not. That's it. That is the question. You don't bother about magnitude 1 or 2 or 3. It follows some period, yes or no?
Yes, sir, periodic.
It follows some periodic like this. Okay. Therefore, this is a periodic signal. It's a periodic signal. Okay. So the time period of the signal t equal to 2 pi by omega. Okay. So don't expect only the direct questions for the semester exam. You have to practice at least basic problems from signals and system opinion textbook. Not advanced level problem, at least basic level problems. So likewise, you may get the problems in terms of odd. Now even function of cos 4 pi t dot u of t. It's the same problem given in terms of odd function of cos 4 pi t dot u of t. Let's check. Problem number 8. X of t equal to odd function of cos 4 pi t dot u of t. So first what we need to do, we need to sketch odd function of cos 4 pi t dot u of t. What is the formula for odd component of a signal? X of t plus x of minus t into 1 by 2. Okay. So cos 4 pi t u of t. So that signal in previous problem we have plotted. Cos 4 pi
Sir,
t
minus
dot,
x of
sorry, minus of x
x of
minus t.
t minus
Thank you. X of t minus of x of minus t. Okay. So cos 4 pi t ut. Let us assume this is our x of t. Now, as per the previous problem, cos 4 pi t ut, we are getting this signal like this. Okay. Or x of minus t, so we have taken as the signal is x1 of t to avoid the confusion. So x1 of minus t we plotted already. That is time reversal of your x1 of t. Okay, the signal will start from here. Okay, x1 of t, x1 of minus t. Now how to sketch the odd component? This x1 of t minus of x1 of minus t. x1 of t minus of x1 of minus t. How to sketch? Signal 2 subtracted from signal 1. That is the magnitude at each and every time instant correspondingly subtracted from the x1 of t. So this information minus 0. This information minus 0. You will get same. Yes or no? This information minus 0 here. So on the positive value of t, you will get same signal. Right? Negative side, this is 0. 0 minus of this value. 0 minus of this. Let us assume this is 1. This is 0. So 0 minus 1?
minus 1.
Minus 1. So your signal would start from
reverse side.
reverse side. Your signal will start from here. Okay. And magnitude is scaled by 1 by 2. So I'll put this is 0.5, this is minus 0.5. Now comment on this signal. So this is your actual given x of t. Okay. Odd function of cos 4 pi t dot u of t. This is the signal. So is this periodic?
no, sir.
Yes, see here. In positive side, it start. In negative side, it start from the reverse direction. Okay. So therefore, this signal is aperiodic signal. The signal is aperiodic. So by this way, any